All right, honors 2. This is our last day of content for algebraic trig. Okay, so this is the review class. As you can see, we've got, what is this, 10 questions here with finding exact solutions. Okay, these are repeats, so I don't know why that worked in there. We've got some practice with identities. And we have just kind of a practice, not proving an identity, but solving using an identity. Okay, the one thing that isn't on here that I would recommend that you look at for the test is solving triangles. Okay, so that could be, ambiguous case. So I'll say ambiguous or non-ambiguous case, right? Finding side lengths, finding angle measures, all that kind of stuff. And then also area of triangles. Okay? If I go back and I look at the unit plan, which I'm doing right now, and I look at the objectives, here they are. Deriving law of cosines, area of triangle, formula law of sines. Okay? So that's really IDs, law of sines, law of cosines, area, right? Applying the 3 above formulas. So, how do we use this to either solve triangles or find area of triangle? You've got Pythagorean, sum difference, and double angle IDs, right? You've got proving trig IDs, which we will do here. And you've got SSA, ambiguous case stuff, and solving equations with and without a calculator. Okay? So I'll say you could use a calculator for non-exact equations. Okay? And what I would suggest is that you just graph for those. All right, so let's get into these equations because we've got a lot to do. And really encourage you to write your teacher, get in touch if and when things are confusing, because this is, I think, the hardest unit of the year. And if you don't have questions, we worry a little bit, to be honest. Okay, so here we go. Question A, cosine x equals -1/2. Well, geez, that's just unit circle. So I'm going to say x is equal to -1/2. So that's going to be either 2 pi over 3 plus 2 pi k, or 4 pi over 3 plus or minus 2 pi k. Okay, so this is in, 2 pi over 3 is in quadrant 2, 4 pi over 3 is in quadrant 3. The cosine is negative in both of those. All right, this is a general solution. We want solutions just between 0 and 5 pi. So let's write that here. So we've got x equals 2 pi over 3. If I add 2 pi to that, that is, I believe, 8 pi over 3. You guys know how my arithmetic is. If I add 2 pi to that again, that is 14 pi over 3. And if I add 2 pi again, I'm outside this upper range. Okay, so these 3 solutions are from this. I'm going to do the same thing with these solutions and see what we get. So 4 pi over 3 is in there. That would be 10 pi over 3 if I add 2 pi. And then if I add 2 pi again, I get 16 pi over 3, which is too much. So this is our answer. Really encourage you guys to check via a graph as well, just in case I've made a mistake. But I'm going to go with those. And let me just check again. 2 pi over 3, 8 pi over 3, 14, yeah. 4 and 10, yeah, I can't subtract from either. Okay. Letter B. 2 sine x minus 1 equals 0. So if I'm trying to solve that, that's the same thing as saying sine of x equals +1/2. and this is between negative 360 and 360, so we're in degree mode, so x is equal to, I'm going to say 30 degrees and 150 degrees. Both of these should be plus or minus 360 degrees K. All right. To save some space, I'm going to try and do this in my head, and that's probably not going to be a good idea, but we'll see. So 390. No, that doesn't work. But I can go negative. So minus 360 would be negative 330, and that's okay. 150, yeah, that works. Plus 360 is going to be too big. Minus 360 is negative. Whoops. Boy, you guys can see my arithmetic skills there. Man. Negative 110. Yeah. All right. So there is our second set of answers to these equations. So this is done. This is done. Next one, C. Letter C. Sorry about that, guys. Closing the window so you don't hear traffic outside. All right, so if I isolate cosine x and C, this is cos x equals negative root 3 over 2. So that means x can be, and we're going to be between 0 and 3 pi here. Okay, so let me get my first two. Negative 3 pi over 2, that's 5 pi over 6, plus or minus 2 pi k, and also 7 pi over 6, plus or minus 2 pi k. All right, so if I use those, we can't have any negatives, and we're going to add the period of 2 pi. So let's see, so we get x equals 5 pi over 6 plus 2 pi would be 17 pi over 6, which is okay. If I add 2 pi again, no. Then we can have 7 pi over 6. And then if we add 2 pi, that's 19 pi over 6, which is also not okay. All right? So maybe I'm going a little bit fast, but these two answers come from this general solution, right? So I take 5 pi over 6. I know I can't subtract 2 pi because that would be less than 0. If I add 2 pi to 5 pi over 6, I get this. That works. If I try and add 2 pi again, no, it doesn't work. It's outside of the range here. It's bigger than 3 pi. And this general solution just gives this. Okay, if I add 2 pi, that would be 19 pi over 6. That's too big. If I subtract 2 pi, it's negative. So there's our answer to C. Check. D now. Okay. Cosine x minus 2 pi over 3 is equal to 1/2. All right. So you know what? I'm going to try and write that. No, I'll just go here. Sorry, guys. So these I'm just going to cross out because they're the same as on that first page. And hopefully I'll fit all the answers to those equations on this second page. Okay, so D, if we simplify that a little bit, I'm just going to say x minus 2 pi over 3. So I'm going to go right to solving for when is this angle, right? Or what angle here, this whole thing, what does this have to be so that the cosine of that angle is 1/2? Okay, and that was x minus 2 pi over 3. If the cosine is 1/2, then that means we've got pi over 3 plus or minus 2 pi k, which is in quadrant 1. And I'm going to go negative, actually. Negative pi over 3 plus or minus 2 pi k. Yeah, and we have a negative here. All right, so then, you know, we have an answer for x minus 2 pi over 3. Well, I want to solve for x, so I'm going to add this to both of those. Okay, so this really means that x is equal to pi over 3 plus 2 pi over 3 is pi. And negative pi over 3 plus 2 pi over 3 is pi over 3. All right. So this is our general solution for x. Now I need a particular solution between negative 2 pi and 2 pi. Okay. Wow. So x is going to be pi. If I add 2 pi to pi, it's bigger than our upper limit, which is 2 pi. Okay, but our lower limit is negative 2 pi, so I can subtract. So this one, if I take pi, I subtract 2 pi, I get negative pi. And then for the second part, pi over 3, yeah, that works. If I add 2 pi, that's too big. If I subtract 2 pi, however, I get negative 5 pi over 3. So we get 4 answers here. All right. D is done. Okay. 40% of the way there. E, sort of the same thing, right, as we just did, except now we've got, you know, sine, 2 sine of this equals 1, so I'm going to divide the 2 first, and I'm going to solve for that. So really we want sine of x plus pi over 3 to be a half. Let's start there. Let's get that blue color. So we want the sine of x plus pi over 3 to equal a half, right? Yeah. So, and that's negative 3 pi to 3 pi is our set of possible x values. So this means that x plus pi over 3 is equal to sine is a half, so that is going to be pi over 6 plus or minus 2 pi k. And the other one would be in quadrant 2, which is 5 pi over 6 plus or minus 2 pi k. Okay, so this means that x is equal to, so now I need to take this plus pi over 3 and subtract. So that's going to be 2 pi, so that's going to be negative pi over 6 plus or minus 2 pi k, or 5 pi over 6 minus 2 pi over 6 is 3 pi over 6, which is pi over 2. Pi over 2 plus or minus 2 pi k. Okay? Saying k a lot. So if I subtract pi over 3 from pi over 6, I get negative pi over 6. If I subtract pi over 3, which is 2 pi over 6, from 5 pi over 6, I get 3 pi over 6, which is pi over 2. All right. So then finally, for our general solution, x is going to be, and I'm going to do the same procedure as before. Take this as my starting value, subtract pi over 2, 2 pi. Subtract multiples of 2 pi from this until I'm outside of negative 3 pi, and then add and get answers. So let's see, we get negative pi over 6 for sure, minus 2 pi is negative 13 pi over 6, which works. If I subtract 2 pi again, no, not going to work. But I can add. So plus 2 pi, that's going to be 11 pi over 6. And if I add again, too large. So 3 answers here from this general solution. And here, if I work through that, well, I've got pi over 2, that's my starting value. If I subtract, that's going to be negative 3 pi over 2, which works. If I subtract again, I get negative 5 pi over 2 minus pi over 2, which is negative 7 pi over 2, which no, doesn't work. And then if I add 2 pi, that's 5 pi over 2, so that will also work. Just kind of thinking about these. Yep. Just double checking. This minus 2 pi is, yeah, negative 7 pi over 2, which is too much. Yep. Okay. So, I think I gotta go back to orange. So this is our answer for E. Check. So for F, very, very, very similar. I'm going to check that one now, but we want sine of x minus pi over 4 to equal negative 1 over root 2, which is kind of a trick form of root 2 over 2. So for F, geez, I think I forgot. I think it was sine of x, was it minus pi over 4? Yeah. Is equal to negative 1 over root 2, which is the same thing as negative root 2 over 2. And so if we see this, hopefully we're thinking 45-degree angle or pi over 4. And we are in radians again. Okay. So x minus pi over 4 can equal its sine. So negative root 2 over 2, so that's going to be either 5 pi over 4 plus or minus 2 pi k, or let's just say negative pi over 4 plus or minus 2 pi k. Okay, and some of you guys have asked this. This angle that we start with doesn't really matter as long as it's in the same location. So this is in location quadrant 4. I could have started with 7 pi over 4. It would have been the same thing, right, if it's a general solution, because you're adding on these periods potentially an infinite amount of time. Okay, so don't worry too much about these. You just got to be careful when you're finding a particular solution that everything matches up. And so we want 0 to 3 pi. So actually that wasn't a good choice because that's outside, but that's all right. Actually, maybe it's okay because I forgot we got to solve for x. So x is going to be 5 pi over 4 plus pi over 4 is 3 pi over 2 plus or minus 2 pi k. And actually this will work out nicely. Negative pi over 4 plus pi over 4 is 0. Okay, so those are our two general solutions for x. Now we got to get the particular solution, which I believe was between 0 and 3 pi. Yep. So let's see, 3 pi over 2, yeah, that works. If I add 2 pi to that, nope, it's outside the range. And then we have 0 and 2 pi. So 3 answers for F. G, H, I, and J. You know what, guys? I'm going to stop there. Make a second video for these second sets because this video is getting pretty lengthy. And what I'll do is I'll put the answers to G, H, I, and J. I'm going to put one here. And then hopefully I'll be able to have some space to put more of them down here. Okay, so I'll stop this video and see you soon on the second one.